We're going to look at the number system, and we're going to start off with in the number system by looking at what we call counting or natural numbers. Now, counting in natural numbers, we start at 1, 2, 3, 4, and these are called natural numbers or natural counting numbers because these are numbers that we would have naturally used a long time ago. Okay, when we were first could think, we would start counting up things. We use these natural numbers to count. Now, from there, what we did was we went to rational numbers because at some point we needed to be able to divide up things into pieces or express things as a ratio. And ratio comes from ratio. Rational comes from ratio. I'm just going to highlight that. Rational comes from ratio because they are to do with fractions. Okay, so these are numbers that can be written as fractions, and they are terminating or repeating decimals. From there, it took a long time after that. We developed rational numbers to come up with whole numbers. And the whole numbers is the counting numbers, but it included zero. Now, it took a long time to come up with whole numbers because we really didn't need zero for anything. Because if you had nothing, we didn't really need anything to express nothing. So it really wasn't, zero took a long time for us to come around and find and to use. But once we came up with the zero and whole numbers, that naturally led to negative numbers. Because once we hit zero, well, we can go beyond zero to negatives. And we end up with our integer numbers. So they kind of, whole numbers, the zero and integers kind of go hand in hand. We have integers because we can now express right to, left to. We have $2. I owe $2. Okay, I go up. I'm at 500 positive 500 meters of elevation. I could be negative 30 meters of elevation below sea level. Okay, this is how we can use integers. And then lastly, and this took after integers a long time after that, we ended up with irrational numbers. And really, these numbers are really hard to find. In fact, for a long time, mathematicians didn't even know that these existed. But they got a hint about this when they started looking at things like pi. So pi is a really famous irrational number. It's approximately 14158 and so on. It just keeps on going on and on and on. And for a while there, people used the approximation. Pi was approximately, they were using 22 over 7, which is pretty close. If you work out the decimal value to that, it's pretty close to the decimal value we have for pi. But although they used 22 over 7 as a rational number, they kind of knew that it wasn't quite right. And it took a long while, but they at some point determined that, well, pi, numbers like pi, it's not quite 22 over, it's not rational. We cannot express this as a fraction. And there are other numbers like this, and the pi and another number called e, which is Euler's constant, these numbers show up all the time. And these are special numbers because they're called transcendental numbers. And they're irrational numbers that show up all the time for whatever reason, and they're just special irrational numbers that we've come across. The types of irrationals that we're going to deal with, these are called algebraic irrationals, things like square root 2. We find them by square rooting things. And square root 2, when we do that, it is not it's not a number that can be written as a fraction. It is, when we do the decimal expansion for this, we get 1.41421, and it just keeps on going forever and never repeats itself. And this is a key to identifying irrational numbers. And these are called, and I'm just going to put these have a name. They're called algebraic irrationals. And this is what we're going to focus on in this unit. Okay, and so here we show a Venn diagram showing how these numbers relate to each other. Okay, so we can see that natural numbers, or the counting numbers, are a subset or entirely contained in whole numbers. The only difference is the whole numbers include zero. And then with outside of that, so inside integers is whole numbers and natural numbers. So when we expand our whole number system and include the negatives, we get integers. And then we can go outside of that and we can include fractions. All fractions, all integers can be expressed as fractions. Okay, so whole numbers, integers, are and natural numbers are all also considered rational numbers. And then outside of that, if it's not rational, it is irrational. So irrational literally means not rational, can't be put into a fraction. And irrational numbers are numbers like root 2. And so this is what our number system looks like when we put it in a Venn diagram. So what I would like you to do at this point is do the Plix interactive, and it will have this kind of Venn diagram that you need to make, and you can answer the questions on which number sets are embedded inside other number sets. And then there's another video on irrational numbers and how we know some algebraic numbers or algebraic irrationals are in fact not able to be put into fractions.